device physics. So in the vertical way we are showing this. So p-type substrate or sometimes called a wafer, on which we are defining to n-doped region, okay, depending for the source and drain. On this substrate you will silicon dioxide, layer of silicon dioxide, which is basically insulating, used as an insulating material in between gate and the substrate. Okay. Then you will find the metal contacts to give the contacts in the drain at the source, okay, thereby completing this enhancement MOSFET structure. So to highlight this point, it has the p-type semiconductor material as body of the source. Okay. 2 n-type oil is diffused in the body of substrate to define the drain and so as is called the enhancement type of MOSFET. So we need to apply certain voltage, positive voltage of the gate terminal to form a channel. By default, 2 p-n junctions are formed, creating to depletion region, so that under normal conditions that without applying gate voltage, there will be no current, flow of currents, flow of charge carriers from the source to drain. Okay. Some metal contact is created at the bottom, so as to connect the source substrate. So sometimes this is known as the body. There is a layer of silicon dioxide in between the 2 n-type well, at which is working as an insulator of dielectric material. Source and body terminal are internally connected or is grounded. So in case the source and body terminal is not connected, short circuited, then you may find the effect what is known as the body effect. We will be discussing this thing also. So n-channel enhancement MOSFET to operate properly. So gate to source voltage that must be applied in between gate and source terminal. Electrons will push towards the gate terminal. What we call is the accumulation phase. Okay, this is the G phase of working, depending on the amount of voltage you are applying at the BGS. So when the BGS is small enough, so electron will push toward the gate terminal and accumulate there as the BGS is positive. Now, if you increase the BGS, so electron hole pairs will be formed. So pushing holes below the towards the body, and more and more number of electrons will be getting accumulated just near the gate. So when BGS reaches a certain value, usually known as a threshold voltage, then there will be established a channel through which these electrons can flow from source to drain and following the flow of current. So to summarize, if the VGS is less than this threshold voltage, if VGS is less than this threshold voltage, there is no channel. If VGS is more than the threshold voltage, the channel is established. Now, if we apply a drain to source voltage externally, then channel will be working as just a voltage control resistor. Okay, so through this resistor, the current may change depending on the drain to source voltage. Now, if the drain voltage is kept at high potential, a drain current will flow. Increasing the VDS, drain current will increase. At certain values of VDS, channel might get pinched off and drain current stop rising. The drain current is not going to be zero, but the rising effect of drain current that will be stopped. So that is known as the pinch off voltage or the saturation voltage. At this point, whatever the current is flowing, that's the saturation current. Now increase the saturation current further. To increase the saturation current further, the gate to source voltage can be increased. Okay, this way the huge amount of current that can be flowed through the MOSFET.